So before we start talking about R, now because it takes time to download the R program, so now just take some time to download the R. So just Google R program in your software. And then after you Google it, just click it in and then download. And then just any address, it works. So let's choose like the first one. And then now just download like which versions that your computer is, Mac or Windows. For me, I'm Mac, so let's hit Mac. And now just download the newest one, the R 4.1.2 package. Just hit download, just click it and then it will just start downloading. So this is your R program. And also besides your R program, you need a platform to do R, which is R Studio. So again, Google R Studio and then click it in. And then scroll it. And then there's a download free desktop IDE. And choose your version, definitely choose the free one. This one, not the RStudio server, the RStudio desktop. Choose this one. And then let your computer download it while we are talking about the Excel and Google Sheet. And then after you download this too, and now we are ready to go to our second part, which is the Excel. Oh, where's my Excel? Okay, here you go. Okay, now take some time to input your X and Y value into your Excel. And then for your R and RStudio, after they download it, just install it. So after you put in all the X and Y, we are going to do a linear regression and also do a confidence interval for the slope. So now After you put in all the data, just highlight these two rows and then insert a scatter plot. And this is how you insert the scatter plot in the cell. And after insert the scatter plot, you are trying to also add in the line. So add the chart element and add the trend line and go ahead and add a linear line. And then after we add the linear line, just double click the line and then let's go to the right panel. And then we can also display the R square and also display the equation. So this is the R square and your equation. And after that, we are trying to confirm our conditions are satisfied. So we need a histogram of residual and also a residual scatter plot. So before we can find our residual, we need to find the predicted value, the predicted y. So we know that our equation is 1.9952 times x. So 1.9952 times our x value plus the y-intercept. So that's the formula. So you can double check your formulas in here if it's the same as mine. And after you input the equation, select the cell, and then you see like when I move my mouse around the lower right corner of the cell, that becomes a black cross. And then slide it. And those are your predicted by y values. And after you get all the predicted y value, now is the time to get the residual. So your residual equals to actual minus predicted. So that becomes actual, which is this cell, minus predicted. And then after you get one cell and also slice it, you get all the answer for the remaining cells. Those are the residual. And now you want to get a residual plot. So you want to select your X value. And also select the residual value by pressing Windows on your keyboard. And then now insert another graph. Insert another scatter plot. So that is the residual plot. And after you enter the residual plot, you also want to enter the residual histogram to double check if the distribution is normal or not. So now only selecting your residual column and insert a histogram. There is the histogram options here. Insert histogram. But now you can see like there's only 3 bins here, like 3 bars. I want some like a better estimate. So now double click the chart and then the right panel just appears and go to the options. The bin size, don't set it to auto, set it a number of bins and try 5. Okay, now that looks good, like normally distributed, bell shape, and symmetric. That looks good. And now we want to check for the conditions. So for checking conditions, we need the first one is to satisfy linear. The second one is random, equivariance, and independence, and normal. So for random and independence, that requires the context of the problem. It's not relating to our plots. For linear conditions, we need 2 things. One is the scatter plot. Looks linear and without any curve. And then also our residual plot looks random enough. No padding and no curve. So that is a good thing. And then for equivariance, we only check the residual plot. So the residual plot is evenly distributed top and bottom, left and right. That is for equivariance. And then for normal, for our residual histogram, the distribution looks symmetric and also bell shape and single peak. So that satisfies our normal condition. So questions so far. So after we check all our conditions, we want to find our confidence interval. So the formula for confidence interval is slope plus and minus T star times SEB. So T star is the inverse T, check it by the table, and also do it from the cell as well. And SEB is equals to S over Sx, the standard deviation for x, times square root of n minus 1. That is our standard deviation for B. So by calculating the SEB, we need first finding the x and also finding the xx. So S means the standard deviation for residual. And Sx means the standard deviation for x. So in order to find the standard deviation, we can use the Excel command stdev and then select the entire column. And then enter. And then also find the standard deviation for residual. Also selecting the entire column, stdev. And also hit enter. And then T star, we can do it by T dot inverse. And then the probability is 0.025 because we are trying to find a 95% confidence interval. And then degree of freedom is 29. So how do we find the degree of freedom? By finding the n. N is the number of observations in the study, which is the number of count of x or y. So that's why the degree of freedom is 19, which is 20 minus 1. And the slope in this case is 1.9952. So that's why our confidence interval, the upper bound and lower bound are 1.9952 plus the T star times the SCB, which is S divided by SS times of n minus 1 of 19. So this formula here is a little bit long because that is our Sx, as standard error of slope, and this is our T star. And we can also copy paste the equation for our upper bounds. and change the plus into a minus. And this is our lower bounds and upper bounds. So after this upper bounds and lower bounds, we can make a conclusion here. Since all our upper and lower bounds are positive, we have 95% of confidence that X and Y are positive correlated. So this is the conclusion for our confidence interval. And this is how you find your confidence interval based on the data. Like let's say I only give you X and Y in the project, and this is how you find your confidence interval for the slope and make the conclusion. And also we can make a conclusion on the R square as well. So the R square is 99.19%. So that means the linear regression line can capture 99% of the variation in Y. So this is how you interpret your R square as well. And then all the numbers are calculated using Excel. So this is how you use Excel to do work. Questions so far? Okay, so this is how you do it on your Excel. And then if your R and R Studio has been downloaded, go ahead and install it while we are talking about how to do it using Google Sheet. So again, on your Google Sheet, it looks something like this. Okay, bigger. And now the first thing ever is just to type in your equation. Upper left. Like type in your numbers. And now just highlight your X and Y. And also insert an image or insert a chart. So they will give you a line graph, but this is not what we want. We want some scatter plots. So in your setup, change your line plots into scatter. Take some time to do it. And then now you are trying to add your trend line, which is the least regression line. Go to customize. Go to series. And then there is a trend line option here. And then this is the line of best fit. And now you want to know what the line is and also know what the R square is. So this is your R square, 0.992. And also you can also label the equation, 2x plus 2.87. So now after we get the trend line, we can also get the predicted outcome. Wait a second. So the predicted outcome is 2 times our x plus 2.87. And then they have the suggested autofill for you. Yes, please. And those are your predicted number on the line. And after you get the predicted, you can find a residual as well, which is they gave you the recommendation, y minus x. Okay, that's what I want. And then also autofill it. So this is your residual. And now again, we want to find our residual plot as well. So highlight the x and also highlight our residual and then insert another chart. Hey, this is our residual plot. Good. So after our residual plot, we also want to find our histogram. So again, highlight our residual and then chart. But now change the scatter chart into a histogram. Okay, done. So this is the residual plot. And that is your residual histogram. So, question so far. Make it line up perfectly. And then after the 2 plots, we can check for the conditions like previously. So our conditions are linear, random, equal variance, independence, and normal. They all satisfy. So now we can find the standard deviation for residual. And also xx, the standard deviation of x. And also t star, and also n, the number of observation. and also T star, the inverse T, and also our slope, which is 2 from the regression line. Okay, so first of all, finding the standard deviation of residual that equals STD EV of residual column. And also finding the standard deviation for X done, and finding the number of ops and also T star, the T dot inverse. So the commands are the same for Excel and Google Sheet. But you're just using different platform. And the slope is scattered from our scatter plots, 2x plus that. So it's scattered from here, the scatter plots. So after we find all that, we can find the upper and lower bounds. So the lower bounds is, okay, let me find the SCB this time, which is S divided by standard deviation times square roots of n minus 1, 19. So that's our SC. So our lower bound is the 2 plus the T star times SC. Okay. Again, copy this and then paste it to my next row and change the plus into a minus. So that is the upper bounds and that is the lower bounds. And after the upper and lower bounds, we can make the same conclusion as well. Questions? So in the project, I will give you like a list of X data and also a list of Y data. And then you do a scatter plots and also a regression line. And then also find the slope and make some conclusions. That's basically what you do for the project. And then for the project, I will not only give you like one variable for X, I will give you multiple X. And then you find which one gives you the best fit. Or maybe you can use 2 variables to predict. And then at the end of it, based on the R square, you find which one gives you the best fit. Or maybe some of it will give you some kind of like chain, like give you some curve on the residual. And in that case, you need to either do some transformation or use another variable. Okay. So hopefully everyone has been successfully downloaded the R and R Studio. So after you download the R Studio, install the R first and then install the RStudio. Because RStudio is a platform for R, so you got to install the R before you can install the RStudio. So for the project, for the extra credit project, it's not mandatory. But I'm highly recommend you to understand how to use R to do the project, because you are a college student and then you will need to be able to do some like programming in the job market. So let's say in the job market, you say like you know how to use R and RStudio to do the linear prediction, then it would be a bonus for someone who wants to hire you. So now let's go. So programming is not only for the one who's major in computer science, but also for everyone basically. So after you download the RStudio, your desktop should look something like this. And then now go to create a new R script. So create another page, like create a new canvas. So just a little summary of what these are. So the first panel here is your scratch space. So you can type whatever on here. It's not running. So even though you make a mistake, just type it in. It's somewhere you save your command. And then for this part here is where you actually run your code. So you copy the code from your Scratch panel to where you run your code and then enter, and then it will just run. And then here is where you see your plot. So those are the 3 panels that you'll be working on. And then here is just a summary of like what variable you define and then what are they. And it's not very useful, but it's informative. Okay, so those are the 4 panels you're going to see on the RStudio. Okay, so now this is our X and this is our Y. So just type it in and then highlight it and then hit run here. Or you can just like copy paste to the command panel, copy paste here and hit enter. It's the same thing. And now you can type in your X and see what's in there, and also type in your Y and see what's in there. So it's basically like a calculator. It's not a programming tool. Don't think like programming is hard. It's just a calculator here. Like you put whatever you want and then they give you the answer. And now I want to plot X and Y. So plot X comma Y. So this is the hint for you, like what variable they take to the first and what variable they take to the second. So copy it down and then run it. So this is your plot. And now I want to find the linear regression for x and y. Then what should I do? So go to ln y tilde x. Then they will give you a summary of what the intercept is and what is the slope is. So this is the slope, and this is the y-intercept. But this is not something we see in the lecture notes. So how should we get like the computer output from like the same output as our lecture notes? Go do a summary here, and then summary means I want more detailed output for my x and y. So summary of ln that. So you see, this is what you see on the nodes. So the coefficient and also the estimate, the standard error, the t-value, the p. So this is our slope. And the top is our y-intercept, 2.87. So this is how you get the computer output. And if I want to put my line on the plot, then do an AB line. So the command is AB line here, and then just put the regression line commands in the AB line command. So this is the line that I'm looking for. This is the best linear regression line. So after the line, I want to find my residual. So before we can find the residual, we find the predicted value. So set predicted equals to the 1.99519 times x plus 2.87053. So this is basically store this number into our predicted variable. So we can see what's in there, what's in predicted now. So a bunch of data. And these data sets are the same as the one that we calculated using Excel and also Google Sheet. And after the predicted value, we can find the residual. So our residual equals to y minus predicted. So this is our residual, which are the same as the Excel and Google Sheet. And then after you find the residuals, now we can do a scatter plot again. So plot, but this time not x and y, it's x and residual. See, those are my residual plots. It's around 0 and evenly distributed top, bottom, right, and left. Questions so far? Okay, and after the residual plot, we are trying to find a histogram. So for histogram, it's just hist residual. That's it. So that is the histogram that we are looking for. And now now let's say we want to find a confidence interval, like the main thing that we want. So in order to find a confidence interval, that is the good thing for use programming instead of like calculating the number one by one. So we can use the programming line, which is confidence interval for LMY tilde X. And the level that we want is 95%. So if we want to change our confidence level in Excel, that means we need to change the T star. And after we change the T star, we need to change the upper and lower bound. That's lots of work. But in programming, we just need to change the number. And then they will give you the confidence interval. The first one is about the intercept. This is about the intercept. And in the S column, in the S row, that is about the slope. So this is the slope. And also, this is the slope. So you can see that the confidence interval are the same for what we found using Excel, which is more accurate, I would say. Questions so far? Okay, so one bonus for you guys. Let's say on the final, I asked you to find the confidence interval for the list of data, for the list of X. Let's say I am asking you to find a confidence interval for the mean of X. Then you need to do S bar plus and minus T times the standard error, right? So you need to first find the mean of X, and then after you find the mean of X, you need to find the standard error, which is finding the standard deviation, and then divided by square roots of n, and then finding the T star using the table. But now you can do that by just one command. So now you can do that by just putting a t-test X, because X is what we want to find a mean on, and then just $sign confidence interval and see what we will get from it. So 95% confidence interval is from 7.73 to 13.27. So you get the confidence interval immediately after you type in the command. So remember, for our second midterm, we need to find the mean, find the standard deviation, and then plug into our equations and find all the other like variables. And now one command is enough. And let's see if we want to do it step by step to find the confidence interval. The first thing is to find the mean. So mean, let's say let m equals to the mean of X, that's what we need to find. The SD is the SD of X, and then run it. And then also run the second one. So our mean equals to 10.5. Our standard deviation is 5.91608. And then the standard error equals to the standard deviation divided by square root of n. So again, the number of variables we have is 20. So here is 20. So that is our XC. So our standard deviation, our equation for finding confidence interval is S bar plus and minus T star times standard error. So we can also find the TE star here by using the command let's see if I install the packet T inverse. No. Then let's find it in Excel T inverse. So it's negative 2.09. So that's our T star. And now the upper bound equals to mean minus T times SE. Our lower bound equals to mean plus T times SE. And see, compare this is what we solved by hand. Compare that to our computer output. So let's see what is our upper and lower bounds and see what we get from using only the commands from the R program. You see, the answer are the same, except for a little bit off because for the T we are using is only 2 decimals. And then they use more accurate T. So, but the answer is close enough, at least to 2 digits already. So that's the beauty of using programming tools. So that's why I'm highly recommend you to learn how to use the R program, because R is the most user-friendly for someone who has no previous knowledge for programming, and also it's free. And then it has so many packages on it. You can do so many things on it. Even though you want to do research in the future, R is enough for you. Or even you want to do some kind of like management in the future, and also R is enough for you as well. So any questions? Okay, so that's what I prepared for today. And then again, I'm highly recommend you to install the R and then check it out what happens in there. And then if you have any questions, feel free to send me an email on, hey, how to use R or how to install it. There's no stupid questions. You can ask me whatever you want. And yeah, that's it for today. And then see you guys on Monday. We will go back to the normal lecture on Monday. See you guys. Bye.